Welcome to my channel Chemistry with DNA. I am NAUMAN AHMAD and today I am going to start one of the most important topics of thermodynamics, that is state variable, path function and state function. So today in lecture number 4 we are going to start some of the most important topics, that is what is state and state variable. State variables. What is the difference between state and state variable, and also what is the difference between state function and path function. These four important terms will be used in today's lecture number 4 of Thermodynamics BSc Part 1. So what is basically state? State is, suppose we have a cup of tea. We have a cup of tea. In this cup of tea we have tea, and the temperature of the tea is around about suppose 27 degrees centigrade. This is the temperature. So it's not a hot, so that's why it is in a cold condition, so we can say it is a room temperature. So if you want to increase its temperature from 27 to, we can say, 50 centigrade, so we are going to increase the temperature of this tea from 27, we can say from cold to hot. We are changing its state. State is nothing. State is just what is the current situation. What is the current situation of a system. So state is nothing. State means what is the current situation. We can say in electronic configuration we have discussed ground state, excited state. Ground state means when it is in normal state, and excited state when we have provided energy and it jumped from lower atomic orbital to higher atomic orbital, we can say it is in excited state. So ground state when the energy is low, ground state when the energy is low, and excited state mean when the energy of that electron, if we talk about the electron, if the energy of electron is high, it is moving the higher energy orbital level, so we can say that it is in excited state. But when it has in the lower orbital, we can say it is in ground state, and it has a lower energy. So state is basically, in thermodynamics you will be familiar with the word state variable, state function and path function. So state is nothing. State is just current situation. What is the current situation? Suppose if you just remove like this, so if somebody asks from you what is the current state of this, we can say it is in cold state. But if we increase the temperature from this, so we can say that it is in hot state. So coldness and hotness it depends upon the state. So state is nothing, just the current situation, current condition. Condition is also, we can write instead of situation. So state is basically the current situation of a system. And so what is system? System, any substance, anything which is under observation, which is under investigation, that is called system. So if somebody tells us the current situation of system, so we can say that is state. So state is the current situation of any system. So far, now see, if you want to increase this temperature from 27 to 50, so we have to bring some changes in it. So what are that changes? That changes. Here one thing more which is important. State doesn't mean solid, liquid, and gas. These states are not included in thermodynamics. Thermodynamics does not tell you about solid, liquid, and gas. Thermodynamics only deals the current situation of any system. Whether it is in hot, it is in cold, whatsoever, the state, the current situation. This word is very important. The current situation of a system is called state, not physical, liquid, solid, liquid, and gas. These states will not be included in this definition. Okay. Now, if you want to change this temperature from 27 to 50, so we have to bring some changes in, suppose like we have to increase the pressure, we have to increase or decrease the temperature or volume, whatsoever. These things, due to which we can bring changes in the current situation of this system. This is a system, because we are just studying this situation, this system, so this is system. Whenever anything which is under observation, a part of which is under investigation, that is called system. Now the cup, this tea inside in a cup is a system. So now we want to change its temperature from 27 to 50 centigrade. So mean we are bringing some changes. So here state mean current situation and variable mean change. Those things which bring about their changes. So here we can increase the pressure, temperature and volume, and we can change the temperature from 27 to 50. So these things will be called a state variable. To understand state variable, you must know about the state function. What is basically state function? State function is nothing. State function deals with initial and final states. State function tells us what was the initial temperature, what was the final temperature. It does not tell about the path. And what is path? It only tells आपको ये बताता है कि किस रास्ते से आया है. It doesn't tell you कि उसका initial क्या था, final क्या था. इसको doesn't deal with it. Suppose मैं आपको एक example से समझाता हूँ. Let me give you an example. Let me remove this. Suppose let me change the marker. Suppose this is suppose we have a graph like this. Okay, this is now see you are standing in the lower energy orbital. Let me make it like this. Now see, if somebody asks from you, okay, you are standing on the ground. If somebody asks from you what is the potential energy, so the potential energy of this is, according to physics, we can say the potential energy of this person here the potential energy of this person can be determined by mgh, and the potential energy is 0. Why it is 0? Because the height is 0. When height is 0, the potential energy is 0. In this state, it is 0. But when you provide energy, if अगर इसको provide energy करें, तो we have to provide this kind of energy. So let me suppose this person. Now see, this person is now at the top. This is called height. And what is the height? Let me write how much height. It is 2 meter. Or 2 meter very small. We can say 2 kilometer. So this person is lying on the top of this hill at the 2 kilometer distance. So we can say 2000 meter, because 1 kilometer contains 1000 meters. So 2 kilometer means 2000 meter. Now see, what is the potential energy of this? The potential energy of this person over here is mgh. There is something. Mgh means plus minus something at the height of something, because it has any height. There is height, because this height will be included in it, and you will multiply with it. You will find out the potential energy. Now, what is state function? The state function is like here. Suppose at this stage the potential energy is 0, but at this stage the potential energy is something. We have something potential energy, so we can say that here the initial potential energy is 0, but the final potential energy is something. So state function tells you the initial and the final condition of a system. Now, what is path function? Suppose somebody asks from you, okay, just इसको यहाँ से यहाँ तक लेके जाओ. तो इस मेरे पास I have two options. What are the two options? These two options are, या तो मैं इसको धक्का दे दूँ यहाँ से यहाँ पहुँच जाए, ठीक है. So this is called path 1. एक तरीका ये है कि मैं इसको यहाँ से उठाऊं और सीधा यहाँ पे ही आ जाए. दूसरा तरीका ये होता है कि मैं इसको घुमाता रहूँ, जिस तरह रावलपिंडी और लाहौर में लोग टैक्सी में आपको घुमाते फिराते हैं ना, यानी यहाँ से ऐसे मैं ऐसे घुमाते आपको यहाँ लेके जाऊँ. अब दिस इज पाथ 1 and this is path 2. This is path 2. Suppose path 1 is this and path 1 is this. This is direct. This is an indirect method. Now, if somebody asks from you what is the potential energy of path 1 and what is the potential energy of path 2, what is the potential 1 and 2? Is it same or different? It is same. Why it is same? Because state function just only tell you the initial and the final state. It does not deal you with the path. इसको ये पता नहीं चलता कहाँ से आया, बस उसको इनिशियल 0 है, फाइनल कितना है उसको इससे लेना देना है. उसको इससे स्टेट फंक्शन only tell you the initial and final. Okay, what is the initial state, what was the initial state and what is the final state. So it does not tell you about the way, कहाँ से आया. No, यानी इसका इनिशियल स्टेट 0 है, यहाँ इसकी कुछ एनर्जी है, तो हम कह सकते हैं कि इसका इनिशियल और फाइनल ये है. बट ये कहाँ से हुआ है ये आपको स्टेट फंक्शन नहीं बताता. अब फर्स्ट करो वर्क डन है. अगर आपसे पूछते हैं वर्क डन किसने ज्यादा की है, पार्ट 1 वाले ने ज्यादा किया है, पार्ट 2 वाले ने ज्यादा किया है. जाहिर सी बात है कि पार्ट 1 में वर्क डन कम हुआ क्योंकि सीधा गया है और ये जरा लंबे रूट से गया. तो पार्ट 2 में क्या है, वर्क डन ज्यादा. अब वर्क डन जो है ना, वर्क डन इज अ पाथ फंक्शन, बिकॉज वर्क डन क्या होता है, वो रास्ते पे डिपेंड करता है, जबकि स्टेट फंक्शन जो होता है वो रास्ते पे डिपेंड नहीं करता. ये कहता है कि आपकी इनिशियल क्या आती है और फाइनल क्या आती है. So I hope you got the idea. State function only tells you the initial and final state. कि जैसे a cup of tea में उसका, अब suppose देखिए this is a cup of tea. Again I am making this cup of tea. Suppose initial temperature is 27 and after some times the final temperature is 10 centigrade. ठीक है? So that it decreases ना, it decreases, temperature कम हो रहा है. So if somebody asks from you, okay, what is the state function? You can say the final temperature, initial temperature is 27 centigrade and the final temperature is 10. So 10, 27 and 10. This is the initial, this is the final. So state function that tell you the only initial and final temperature. But के path function आपको ये बताता है कि किस तरह हुआ है, 2 step में हुआ है, 3 step में हुआ है, आहिस्ता हुआ है, जल्दी हुआ है. So this path function tells you the way, the method and mechanism and whatsoever the thing. वो चीज़ें सारे पाथ फंक्शन में आती है. लेट मी गिव यू वन एग्जांपल फ्रॉम ऑर्गेनिक केमिस्ट्री. यू माइट हैव स्टडीड इन FSc where I think SN1 and SN2 where you there are two. Let me give you example of organic chemistry. In organic chemistry there was a reaction. Suppose bromine was there and we are going to introduce this OH with this. Suppose so the final product will be like the same and bromine will be removed. Now see this there are two methods. Now one is called first. There are two methods. Number one, suppose इसमें ये हुआ होगा कि this bromine आहिस्ता आहिस्ता bromine जा रहा होगा. ठीक है, तो सबसे पहले स्टेप में क्या होगा, सपोज लेट मी राइट, ओके, एक कार्बोकैटायन विल बी फॉर्म्ड इन द फर्स्ट स्टेट. दिस इज कॉल्ड प्लस, दिस इज कॉल्ड कार्बोकैटायन. इस कार्बोकैटायन पर OH. नाउ सी दिस OH, दिस इज सिचुएशन नंबर 1. OH यहाँ से हमला भी कर सकता है और OH यहाँ से भी हमला कर सकता है. दे कैन नॉट टेक फ्रॉम राइट साइड, फ्रॉम बोथ साइड, right side, left side. So suppose this is step number 1. In the second step number 2, suppose this OH is formed like this. या आप कह सकते हैं कि इसके साथ एक और कंपाउंड कैसे बन सकता है. Suppose this is another compound, 50% inversion, 50% retention will be formed. Now see this is, here are the two steps. दूसरा मेथड इसके पास क्या है, the second method, suppose ऐसा ही हो सकता है. second method में होगा यही, ब्रोमीन धीरे धीरे से यहाँ से जाएगा, ब्रोमीन जाएगा और उसी समय उसी टाइम पे OH यहाँ पे आ रहा होगा. तो एक ट्रांजिशन स्टेट भी बन सकती है. कौन सी, कि ब्रोमीन आहिस्ता आहिस्ता इट विल बी रिमूविंग एंड OH विल बी अटैकिंग ऑन इट. ठीक है, सो एक कॉम्प्लेक्स कंपाउंड बनेगा और थोड़ी देर बाद के बाद आप देखेंगे कि यहाँ पर आ जाएगा OH आ जाएगा, बल्कि इसको इस साइड पे OH यहाँ पे आ जाएगा और बाकी चीज ऐसे और Br निकल जाएगा. दिस इज स्टेप 1. स्टेप 2. नाउ सी, इसको हमने कहा था, दिस वाज वी जस्ट स्टडी SN1. SN1 वाज द रिएक्शन विद न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन टू स्टेप रिएक्शन, ये टू स्टेप में था, एंड दिस इज SN2, इसमें क्या था SN2। सपोज मैं कहता हूं कि इसकी इनिशियल एनर्जी, सपोज द इनिशियल एनर्जी ऑफ दिस इज 100 जूल, and now the final product of this energy is 80 joule. Now we can say here the energy is 80 joule, 100 joule, the energy is 100 joule, and here the energy is 80 joule. So if we introduce this for a graph for SN1, we just make a graph for SN1 and SN2, so you will get the idea. Suppose, now see, here energy is there. So now see in the first step, suppose energy is 100, so we can say this is the reactant, and because there are two steps, step 1 and step 2, so we are making 2, and suppose this is product. Let me write it. This is step 1, step 2, and this is the final energy, initial energy, and this is the final energy. Here the energy is 100 joule and this is the 80 joule. So this is step 1 and step 2. SN1 के लिए हम इस तरह का ग्राफ बनाते हैं. For SN2 we just make like the same. This is 100 joule, so we can say this is the reactant and this is product. We can write this is 100 joule and this is 80 joule. In both cases the energy difference, enthalpy of this energy, enthalpy in the SN1 and SN2 is the difference between 100 minus 80 is 20 joule. And here also 100 minus 80 is 20 joule. Both the cases the energy difference is 100 joule. But here यहाँ पर दोनों का आंसर तो सेम है, लेकिन what is the most important? The most important, it is in two-step reaction. It is a single-step reaction. Here carbocation is formed. Here carbocation is not formed. Here complex compound is formed. We can say there is complex oxidation state is formed over here. Complex state is formed, activated. We can say. So यहाँ पे देखो, यहाँ पे ये पता चल रहा है कि टू स्टेप में हो रहा है, यहाँ पे एक स्टेप में, लेकिन इनिशियल देखो ये जो है डिफरेंस है. जो स्टेट फंक्शन होता है, स्टेट फंक्शन आपको ये बताता है कि इनिशियल क्या आता है और फाइनल क्या आता है, इनिशियल क्या आता है और फाइनल क्या आता है. जबकि पाथ फंक्शन आपको ये बताता है कि कितने स्टेप में, 2 स्टेप में हुआ है, 1 स्टेप में हुआ है. यहाँ पे 2 पीक है, दिस इज पीक 1, दिस इज पीक 1 एंड दिस इज पीक 2. Peak 1, peak 2, there are this reaction involved in 2 steps, and peak 1, this is peak 1, and this means it is only 1 step reaction. So path function आपको रास्ते का बताता है, जबकि state function आपको only initial और final बताता है. तो this is the most important difference between state variable, path function and state function. I hope you enjoyed the video. Again, is there any question you can ask in the comment section. Take a very good care of yourself. Assalamu alaikum.